Welcome to week 6, where we learn about the power rule. The power rule says that if f of x equals x to the n power, then f prime of x equals n times x to the n minus 1 power. You might be asking yourself, well, what does that really mean? That means if we have an equation that is a power function and we want to find the derivative of it, we're going to multiply the original exponent by the coefficient in front of the equation. Then we're going to reduce the exponent by 1. Really, it's a pretty powerful tool that's easy after you've seen a few examples. Let's work some. In our first example, f of x equals 4 times x to the 7th power. We want to find f prime of x. Once again, to do this, we're just going to take and multiply the coefficient and the exponent. So we're going to take 7 times 4, and then our exponent becomes 1 less. So instead of to the 7th power, we now have to the 6th power. So the derivative, or f prime of x, equals 28 x to the 6th. Looking at example 2, y equals negative 3x squared plus 6x minus 12. We want to find dy dx. You'll notice your book uses a lot of different terminology for derivative. We can even call it f prime of x. We can call it dy dx. You'll see both of those options. It really doesn't matter. It's asking you to find the derivative. Once again, we're going to use the power rule. And we're just going to do this one term at a time. So first we'll look at the negative 3x squared. The exponent of 2 comes down and multiplies by the 3. So we'll have 2 times negative 3. We used to have x to the 2nd. We're going to reduce that by 1, so that would be x to the 1st. And obviously, you know, we can just leave that as x. Plus, we're going to take the exponent, which originally is 1. 6 times 1 is 6. It was originally x to the 1st power. Now it would become x to the 0. Minus, okay, now here we have negative 12. We don't have an x, so therefore we don't even have an exponent. The derivative of a constant is 0. Right now that looks kind of messy, and that's not how we would want to leave it. dy dx is going to be equal to negative 6x plus 6 times x to the 0 is just 6. So when you're taking the derivative of a constant, that term will cancel out. The derivative of x to the 1st power is going to become a constant. The derivative of x to the 2nd will become just an x term. You'll notice all of them drop an exponent. Another power rule example could be used if we're asked to find the derivative of y equals, in parentheses, 5x plus 4 quantity squared. Now a lot of people are tempted just to multiply that 2 down in front, but we can't do that. This is in fact a special type of rule that we'll deal with later. Right now, the only way that we can do this is first expand it. So using FOIL, 5x plus 4 times 5x plus 4, you're going to get 25x squared plus 40x plus 16. That's actually our equation that we want to take the derivative of. So y prime would equal 2 times 25 x to the 1st plus 40. Remember, that would be x to the 0, which we don't need to write. So our derivative is 50x plus 40. The power rule is very important stuff. It's basic, but it's very powerful.